Good morning. Good morning. How's everyone doing? Awesome. Okay. I think I'm going to get started. So let's get cracking. Awesome. So this talk is about preparing for success. It's the top deployment do's and don'ts. So quick introduction. This is Karthik Sekar. He's our solutions architect and also does professional services worldwide for Couchbase. And my name is McCloy. I'm the manager for the support team for EMEA, and I'm based in our office in Manchester in England. So basically, the bits I'm going to tell you today is going to make my job a lot harder because this is all the easy stuff that we get to deal with in the support tickets. So kind of giving you a little insight into what we have to work with. Excellent. So this is the agenda. We're going to start with a little bit on OS tuning, some of the most common issues that we see, especially from the support side, from customers. Then we'll talk a little bit about platform tuning, some of the configurations and things you can do. We'll talk about bucket recommendations, so just some basic things that you can do on your bucket settings to get the best kind of reliability. And then we'll talk about sizing and why it's crucial. So sizing is really important. It's often overlooked. You know, you start out with one size, you grow your cluster, your use case goes up, and you're not looking at that and monitoring it, but keeping it sized correctly, and obviously that's going to run into issues. We'll talk about best practices with our views and our indexing services, and then the last bit is the breaking point, and this is really crucial to figuring out. Before you get to that point, how do you make sure that you tested that and I don't want to give away too much, but that it's crucial to making sure you have a very reliable and performant cluster. Excellent. So we're going to start with some OS tuning. Maybe a raise of hands. In the room, how many people are using Linux servers mostly? Excellent. So it looks like a majority of you. Windows server users, a few in the room? No, you don't have to be embarrassed, it's fine. Excellent. Okay, so Couchbase, as you probably know, is supported and does run on Linux, Windows, Mac. It's pretty unique in the NoSQL space that we do have so many different platforms. So we do fully support all three, and so I'll give you a little insight on some of the bits that are important. So as you can see on the slide here, it's got the first one is disabling THP. This is transparent huge pages is a operating system feature that was introduced a few years ago. It wreaks havoc with any system that uses a lot of memory and has to be high performance. So basically any database system has this sort of issue. So that's probably the number one thing that customers miss out when they set up a new cluster. They'll raise a support case, hey, our nodes automatically failed over, what's going on? The majority of time it's THP is still enabled, so it's not just recommended, it's hugely highly recommended, so definitely look into that and disable it if you want to make sure you've got a reliable system. The next one is using XFS file system. It varies depending on your workload. If you're going to disk a lot, if you don't have a high resident ratio, we found that XFS is certainly more performant than something like ext4. So just a nice little tip, you get a little extra performance with XFS. And then the next one is create swap space. The reason for this is kind of just a safety net. So you really don't want to be using swap with Couchbase. Our product is really designed to run from memory. You want to run your process and your application needs to run it from memory to get the best performance. But if you're, as I mentioned before, if your sizing is incorrect or something else on the machine suddenly starts using memory, you don't want that to take up the memory that's crucial for keeping your cluster running smoothly. So that's why we do recommend that you create swap space as that protection. And so the last one here is setting your swappiness to 0. And so that is, you want swap space defined as a protection, but you don't want the operating system to use it unless it has to. So that's kind of saying, by default on Linux, it's set at 60. If you wind it right down to 0, it tries as little as possible to use swap. It uses as kind of the last resort. And that's sort of more performance kind of tuning that you can do. So these are kind of the top ones on the Linux side. Okay, so moving on to Windows. Number one thing that we do see is TCP ephemeral ports. This is all of our documentation. When you install the Couchbase server on a Windows machine, the last step it'll say, do you want us to automatically set this for you? So it's pretty much automatic, but just something to be aware of. And it's not just with Couchbase Server. If you run your clients on .NET on Windows, for instance, you need to be aware of this as well. And basically, there's a registry setting that will just increase the number of network ephemeral ports that are available. Okay, and the next two on Windows are tuning the virus scanners and your backup utilities. Now the reason that's on there is this applies to Linux as well as Windows, but it seems to be a bit more common with Windows, especially with virus scanners. A very much wider usage on a Windows server than on Linux. And what we're saying by saying tune is you need to make sure that you've configured your virus scanner not to scan the V buckets or the on disk representation of your data. And why this is sometimes your virus scanner, the way it works, and same with the backup utility, when it goes to scan that the V bucket on disk, it will lock it and it won't allow other applications to go and access that because it doesn't know if it's safe or not, right? The problem is we're a very, very high performance system. So when that virus scanner is locked to your V bucket and it's scanning it, we're still streaming data to it, and basically it'll never catch up. And so it'll sit there, sit there, and sit there. And if you can imagine if that's just sitting there, our compaction process won't kick in, and your disk will basically fill up. So really, really important, both with virus scanners and backup utilities, that you don't have them accessing the V buckets directly. You might be asking, well, if I need to back up my data, so how would I do that? We provide our own backup utilities that will extract the data out of the cluster and write it back to disk. So it's perfectly fine to back up that part of the data, but not the live V buckets writing down to disk. And so that's our recommendation is to use our backup utilities essentially. Okay, so I'm going to go on to a little bit of platform tuning. A lot of our customers run on virtual machines, run in the cloud, that sort of thing. I used to say about 60%, but now it's about 80% of the clusters that we support are running in virtual environments. Some of the stuff might be obvious, but it's definitely worth pointing out. The first one is avoiding a single point of failure. And I love it. I got a support case, and one of the customers said, "Oh, we've shut down the node, and my whole cluster's gone offline." So, "Oh, that's very unusual. That shouldn't happen. What's going on here?" "Oh, we've rebooted the machine, and the whole cluster's gone." Okay, let's talk about your virtualization. How have you set it up? "Oh, we've got an ESX machine, and our entire cluster is VMs on this one machine, and we rebooted it." What? What are you thinking? Come on, that's ridiculous. So, things like if you're using SAN storage, we highly recommend you don't do that. But if you do have a SAN backing your virtual environment, maybe use our server groups, our rack zone awareness feature, and split up your SAN so you've got at least a couple different failure zones or whatever your SAN provider is able to provide. They have different terminologies depending on the vendor. That sort of thing. Make sure you've got redundant networking, all the normal stuff you do on a main server. And as I just mentioned, can you please hold the questions to the end, because we've got a lot to get through, and we'll take questions at the end. Okay, so the next one is don't overcommit your resource. Again, very common issue with virtual machines. It's not unique to Couchbase, but essentially, when we talk about the sizing in a bit, we'll say you need to have this many CPUs. That doesn't mean you can run 100 VMs with 4 physical CPUs. It doesn't, nothing's for free. So don't just think that because it's virtualized, you can just ramp it up as much as you want. The sizing applies to physical kind of actual hardware. And avoid live migration. So this one it's got some subtlety to it. So you might think, hey, live migration is a great feature. That's exactly what we do with our virtual environment. That's why we're using VMware or whatever. The reason why this is an issue is on Couchbase, we have a cluster manager, which is a real-time system. And the way that live migration works on VMware, for instance, is it actually will kind of slow down the CPU and so it can have enough time to transfer and send the virtual machine to the other physical machine. And there's actually a little millisecond gap that it does stop your machine when it moves it across. They don't like to say that. They don't advertise it as causing an outage, but there's a little tiny slight outage, that last little blip as it moves it to another physical machine. Our real-time system doesn't like that. It doesn't handle that kind of loss of CPU, basically. And when it tunes it down due to the migration, you're going to lose that performance. So what we advise is we have our built-in functionality to take a node out of the cluster, rebalance it, and then add another node somewhere else. Instead of using the virtualization features for moving the virtual machines, just use our built-in Couchbase functionality. It does exactly the same thing, but it works with our real-time cluster manager in a much more performant way. Okay, and so the last one is increasing the auto failover threshold, and this is like I was mentioning with the live migration. With virtual machines, because they've got varied workload patterns and resources might be used by other virtual machines on the physical machine, we get false positives, so your node will automatically fail over when it shouldn't sometimes. So we advise to just increase that threshold a bit more than you would do on physical machines, so you don't get those false positives, essentially. Okay, I'm going to move on to system clocks now. So it's quite important to actually have all your Couchbase nodes in your cluster have the same time. And so we use NTP, so a network time protocol is a very common way to ensure that they're all the same time. And where this can come into effect is we've got a feature in Couchbase which is document expiry using a TTL or a time to live. So you might say, I need this document for 3 hours and automatically delete it after 3 hours. Now what can happen is the time to live isn't cluster-wide. It's determined by the individual machine that document happens to reside on. And so if you can imagine, you said, oh, I've got a TTL of 3 hours, then you add a new node into the cluster, and it's clocked 3 hours out, it's going to delete that document immediately because it does it locally with the local time of that machine. So it's really important to make sure that all your nodes have accurate time. It doesn't have to be super accurate. It's not like Stratum 1, nanoseconds or anything. But just make sure it's within the thresholds that you have for your TTLs. And we do have another feature coming into Couchbase, which is cross data center replication with last write wins, and basically that will absolutely require NTP because it will determine when you synchronize documents between multiple clusters, it needs to have very accurate time to do that. Okay, server quota. So server quota, the best practice here is to set a maximum of 80% of your total RAM on a system. This is because you need enough memory left for things like your file system caches, your other bits of, other things running on your operating system. Don't set it to 100% because it will just use the entire memory on your system, and then if you're running Linux, for instance, the OOM killer will actually just kill off Couchbase because there isn't any RAM to run anything else. So just tune that down to 80% by as kind of a best practice. It's not set in stone, so if you've got a terabyte of RAM, you don't need to set it to 80%. Use common sense. If you've got 5 or 10 gigs for the operating system, that's absolutely fine. And then monitoring, just to make sure that you're not using more memory than you expect. Okay, so the bucket tuning, two very simple things here. You should use as few buckets as possible. So even if you don't have operations running to a bucket, if you don't have, you might have one up a second, it still uses a resource on the system. So it's much better if you can to use things like key prefixes and have a single bucket or a few buckets and have multiple documents into that smaller amount of buckets. You'll have much better performance. It really helps keeping a reliable and performant cluster. And the next thing is disable flush on production buckets. It's happened more than once, unfortunately, where we get a support case and the customer says, hey, my data's gone missing. And we say, oh, you flushed the bucket. So I don't know what we can do about that, but we have to restore from backup. So it can accidentally be triggered. So just make sure if you're on a production bucket to disable that. Okay, and the last thing I'm going to talk about is replica recommendations. So the rule of thumb that we kind of recommend is have one replica for up to 3 nodes, up to 5 data service nodes, and then 1 or 2 replicas if you're between 5 to 10 nodes. And if you want to have 3 replicas of your data, you should really have 10 or more nodes in your cluster. And that's kind of, again, there's a fixed amount of resource and system resource that's required to maintain those replicas. If you're trying to have 3 replicas with 3 nodes, it's going to overload your system if you want to get to the high performance kind of figures that we're able to provide. Excellent. With that, I'm going to hand it over to my colleague Karthik and talk a little bit about sizing.
Good morning, everyone. So the web, mobile, IoT applications play a critical role in success in today's digital economy, which requires a massive amount of data to be handled, and the response time is also crucial. So let's see why sizing really matters. So one of the most common support issues that we have today is due to under-provisioned clusters, right? So we want to make sure that the cluster is provisioned properly to handle the data, and also make sure that we have a low latency access to handle the performance demands from the business. So, and high availability part, so if you could look at today's mission critical applications, high availability is no longer good to have, but it's must to have. So if I had to throw a little bit on the hardware minimum, so it's easy to remember, it's going to be 8 gig RAM and 8-core CPU. And when I say 8-core CPU, you could understand that you could need 1 core per bucket, 1 core per view documents if you're using views, and 1 core per XTCR, and 1 core for every 10K mutations. When I say 10K mutations, it could be reads, inserts, and deletes. And regarding the storage part, just have to make sure that have local storage as possible. So as Ian mentioned, try to avoid SAN. So normally people, we have questions talking about, like, can we have Couchbase on top of SAN? So although technically it's possible to have Couchbase, and we do have customers who are using it and we do support it, but it's always local storage is preferred. The reason is you don't want to have your processing over there and storage over there, and it's going to have bottlenecks in terms of it. So the whole purpose of shared nothing architecture of Couchbase goes for a toss when you have SAN. So try to avoid centralized file systems. So it's always to have local file systems. It could be SSDs or even spinning disk. So in RAID, you can have it either 0 or 10. In Couchbase, redundancy is taken care. It's just that for throughput, you can have RAID. So sizing Couchbase cluster. So Couchbase introduced like 4.x, which last year, so which introduced a new feature called multi-dimensional scaling, which will allow you to scale different services independently. So which means that I can have different set of nodes taking care of different purpose. So if I have like until 3.x, we had like multi-dimensional data service across which has the same hardware configuration, but in multi-dimensional scaling, you can have scale up, you can have different set of hardware configurations. You can scale up basically for index services. Index services needs more memory and storage, whereas the CPU would be more crucial for the query, but query service may not require storage and memory. Whereas data requires more memory because Couchbase is a memory-first architecture. So you can have, in a cluster of 10 nodes, you can have like 2 index nodes and 2 query nodes, and say rest of them are data nodes. So what does it help? It helps for workload isolation, right? So, and you still have the indexes in a centralized place. So in a typical NoSQL deployment, indexes are scattered together. So in case if you want to run a query against it, so you'll have to check in each and every nodes. So here it's going to be a centralized place. So the throughput and the query efficiency would be more when you have separate index nodes. So this is going to help Nickel and the global secondary index. So we'll talk about how do we size it for each and every set of service nodes. So starting with the data service. So data service, as I mentioned, is pretty much, it's like a previous version of Couchbase. So enough RAM to be there for the cache reads. So Couchbase, again, it's a memory-first architecture. You want to have the data in memory. So Couchbase handles the data in memory as well as in persistence. You need to have both enough memory as well as disk. And the CPU here is primarily for views. If you are using the older version, so you might be aware of the views. So you can still, the CPU is mainly for the views and XTCR. So to start with, it's always recommended to use 3 nodes, and the minimum requirements for a data service is like 4 gig and then 8-core CPU. So index service, as I mentioned earlier, so it's primarily a disk and I/O based. So there are 2 types of indexes: global secondary index and memory optimized indexes. So global secondary index is sort of a disk space which uses external caching engine, and memory optimized indexes are the ones which got released in 4.5, which will allows you to fit the entire index in memory, which is going to have extreme high performance. So you're going to have the index fit into the memory, so you have to size it in a way that the index fits into the memory. So the advantage what you get is, if I have to give an example, if you are doing like if we have to index say 20 million documents, it's going to take say a couple of minutes to index it in memory optimized indexes, whereas in the global secondary index it's going to take you between 20 to 30 minutes. So that's awesome as memory optimized. So for sizing it, you just have to have as much as RAM required. And again, for high availability, you need to have at least 2 nodes. Query service, as I mentioned earlier, so its main focus is on CPU, whereas it's very low on RAM and the disk requirements. It's optimized for multi-core systems, so you can have powerful machines with multi-cores just for query, and the requirements are minimal for the RAM and disk. So let's look a little deep into what are the factors which are driving the sizing. So if I have to put it, there are major 5 factors which are driving the sizing. So one of these factors it's going to determine, or it's going to drive, and the rest of the factors is going to get along. So first is a RAM, disk, CPU, network, and data distribution safety. So if I have to say RAM, it's very important to keep the working set in memory. So when I say working set, which means that the total set of documents in memory. So Couchbase being both in memory and as well as persistent, so you want to have as much as of documents in memory so that you can serve it from the RAM. It's going to be super fast when you have it. So so what all it contains in the managed cache is, like, it has the working set, so which includes the active and replica. So you need to make sure that you have enough memory to fit in the replicas as well, because you don't want to lose in case of inevitable failure. You don't have to read from the disk when you want to promote the replicas to active. And also there is a little bit of caching that you might have to leave it headroom outside the bucket quota. That is for the indexing for views. So in case if you're using views, make sure that you still have some headroom outside the bucket quota. So the resident ratio is one of the most important thing to consider. So it shows that how much percentage of active documents that are residing in memory. So typically when you have 100, which means that you have 100% of the data which is available in memory. So you can actually, this is one of the important KPIs. If you look into the bucket stats, it's per bucket basis, so you can look into it. So typically you want to have your working set. It depends on your business use case, like how much percentage of memory you're going to have it. But from the field, we would say the best recommended value is not lower than 20%, because you have the documents in memory always, so it's going to wait. Make sure that you have a monitor on this one, so make sure that it doesn't go below 20%. It's not that you can't go below 20%. There are customers who are using like 10%, but the problem is like when you start going down, so you're going to do more disk fetch, there's going to be more cache miss, right? So you should be aware that you're going to hit the roof soon when you're hitting 20%. And there are certain indicators available, so they are like the metadata overhead, so which will pop up an email alert, so which indicates the bucket is now using over 50% of the data allocated for metadata and keys. So I just want to go back here and I want to explain the metadata part here. So until 3.x, we will have an option, or the earlier version didn't have an option to completely evict the data. So right now we have two options from 3.x, which is full eviction, and we have the metadata also. So we can actually do a we can evict the metadata as well when it goes beyond that limit. But the problem is when you do the full eviction, so in case if the document is expired, so the metadata is not there in memory, so it has to go disk fetch and make sure that it's had to return saying that it's not there in memory. Right? So that's going to be additional disk involved when you have TTLs which got expired and the metadata is not there in memory. So it has to do a disk fetch and read the metadata saying that it's already expired. So it's going to add more complexity. So it's better to have, size it properly, that you have the working set and also metadata in memory. So disk. So there are various things which contributes to this. So one is the I/O and the other one is the space. So we'll see what are the factors which contributes the I/O and what are the things which contributes to the space. So sustained write rates. So the second factor, disk is actually, if I have to say, Couchbase can handle burst of writes. So the application could be completely unaware of it. It could be able to work in a normal fashion if the disk is caching up. So sustained write rate means that if the disk write queue goes up, if you're doing more writes, over a period of time, it's going to get saturated. It's going to come down to a value, and the other one is the rebalancing capacity. Whenever you want to add new nodes, whenever you want to do an upgrade, whenever there is a failover, you have to do a rebalance. So that's going to contribute to the disk I/O. And backups, of course, if you're taking backups, there's going to be a bit of I/O which is involved, and depends on the percentage again. So as I keep saying, the doc resident ratio is very important because it's going to do read it again. If you're going to have it in the disk, it's going to fetch it to the memory and it's going to put it back. So it's going to take a while. So an XTCR, and again, it's going to read it. So although we have in memory, so when you don't have it in memory, it's going to contribute back to the disk. Disk is going to take a hit when you don't have it in memory. As simple as that, if I have to put it. And of course, views and indexes. So these views and indexes do not use a global secondary index. So these things are again the earlier architecture, which is scattered. So still there is a disk I/O which is involved for reading the views. So views are a little slow when compared to the GSI or memory optimized indexes. So I'll talk about views in detail in the coming slides. So, and of course, compaction. Couchbase is an up-and-only store. All the updates and inserts are going to add like a new version of a document. So only during compaction, the old revision data will be deleted. So compaction also it takes a bit of I/O. And space is usually not a problem, but if you're in AWS or in any cloud, so you have to make sure that you have sufficient headroom for the disk. So you should try to size it 3x times your data. So you're good. So that's why we had to include it. So you should keep that in mind, that it's a combination of active data, replica data, and the index data. So disk writes are buffered. So as I mentioned, because of a caching layer, Couchbase can sustain burst of writes. So where the underlying disk could be completely not matched by the memory layer, but still the application works perfect and understands. So you have to keep an eye on the disk write queue. So disk write queue is one of the features, like KPIs available on the bucket stats, so you could keep an eye on it and make sure that it grinds down. So over a period of time, it has to go down. You can check out the average age for the documents, for how it's going to commit. So if it's going to getting above and above, then it means that your disk is not able to handle the throughput. So you should try to size it correctly. So disk throughput is often affected by the speed. So SSDs are faster than the spinning disks are faster than the EBS. So, and there are a few customers who are using Fusion IO cards, so which can get them like over 150K operations per second, and even in a cluster wide, we can do like 1 million writes per second. So the best practice here, again, as I said, so for this disk, so you need to have like 3x to handle the append-only compaction and backups. And the best practice for the views, if you're having it, so you need to have the data and the views, different paths for views and data location. So CPU and network. So mostly the bottlenecks for sizing would be either on RAM or disk. So CPU and network is not a major one, but you still need to understand that they do contribute in case if there is a resource crunch. So main thing is like the disk writing. When there is too many views, there is too many compaction which is going on, and there is tons of XTCR mutations coming in. So these things affect the CPU. So I just want to reiterate what I mentioned before on the CPU. It's like you need to size it accordingly. So it's one core per bucket, one core per design document, and one core per 10K mutations, and one core per XTCR stream. So just make sure that you have it correct. So, and in case if you don't get these stats, Couchbase has a web console which gives you a near real-time stats. So if you see that the graphs starts breaking, so you could understand that it does not have resources to populate the graphs. So the first thing you should look at it is if you have sufficient CPU cores to do it, because that's the first thing will be affected, not on the application side. It'll try to avoid, because every second there are multiple stats or hundreds of KPIs are being collected. So that's not going to take a hit on that. So have to make sure that the CPU is properly sized. So network, it's again least when compared to RAM and disk, but it's also crucial, mostly because network is what driving the client traffic, and also the replication in case of writes, because it has to replicate the data, and while during the rebalancing and XTCR. So during rebalance, it's going to pull the data from one node and it's going to distribute across the cluster. So you want to have like a high throughput, low latency network so that you can get the data as quickly as possible. So when you're using WAN, you just have to make sure that the WAN is configured correctly, and because Couchbase can saturate the WAN traffic, you make sure that there are certain network configurations that you can do it for tuning the XTCR to make it fast, to make it slow, right, based on the requirements. So low latency, high throughput network, as I said, like if you're gonna have like a 10 gig network, you'll get somewhere around like 200 to 150 microseconds. And we have done testing on a single gig network, which will range like around like 500 to 600 microseconds. So from the application side, you would see around like 10 microseconds. As I said, like if you have a good 10 gig network, you will have the data. And again, it depends on the size of the data. So if you're going to have like 500K object versus 10K objects, it's going to, the smaller the object, faster you can get it. So we'll look into the views. So before jumping onto the views, I'm going to talk about a little bit. So we'll come back to the fifth factor, which is the data distribution, once we cover the views part. So there are multiple ways you can get data out of Couchbase. So the first and the most preferred way of doing it is using the SDKs, because SDKs are smart clients. These smart clients know where exactly the data lives. So if I know what key I'm going to do an operation, I can directly connect to the memcached of the particular node, even if you have n number of nodes in a cluster. So it makes life easy and can access the data as quickly as possible. So the best and the most efficient way is to use the SDKs available. There are other options right now, like global secondary indexes, which is useful for the nickel. So nickel uses a global secondary index to get the data. You can use either standard GSI or memory optimized GSI. So these new features which was added in last year's 4.x, which helps you to run ad hoc queries against it if you're not sure what key that you're going to access for. And the views should be considered as a least among the other preferred ways, because views are a little slow. It's again disk based. It's not going to use memory, so it's going to use, of course, it's going to use a little bit of the file system caching, but it's still a disk based operation. So, and it's still good for any aggregation, but you should try to see if you can migrate your queries to nickel, or using GSI rather than just taking on with views, because nickel gives you a lot of freedom, flexible way of querying the data. So best practices: avoid computing too many things on a view. So you should not have like a big 150 lines of JavaScript code to compute a view. So try to avoid it, and check for attribute existence. So before you do any operations or filtering, just make sure that the attribute exists. So you'll have to check on that, and have a pre-filter condition to check if there is a document type. So I can have a filter in Couchbase, if I have to name it. So in a bucket is like a file and cabinet. I can have different type of documents, different document types inside a same bucket. So if that's the case, so when I'm running a view, I can make sure that it matches my document type before I do any operations against it. So I can put a condition to check if this is this document type. I'll show you some example in the coming slides. And map only what is required. Do not emit the complete document, because that's not what it is for, because there are better ways to handle it. So if the view condition is matched, just return only the keys, or maybe whatever fields that are required. You should not emit the full document, because the performance is going to be very slow, because you're going to read it from the disk. And if you can get the keys which matches the condition, the best way is to do is use a bulk get, or do a normal get from the SDKs. So, and try to try to use the built-in reduce functions if possible. So if I have to give an example, you have to see, you can put a condition to see if this particular field exists. So I'm going to check the condition if the first name exists, and then emit the first name. So I'm going to check a condition saying that it's exists, then emit it. And next one, I'm checking this view is applicable for a person. So I want to make sure that it exists. The condition is like doc type is person, and the doc birthday is defined. So I'm going to emit the first name, last name, and emit the birthday as well. So the design consideration for views, if I have to put it. So indexes are allocated per design document. If you recollect, when I was talking about the CPU sizing, I was talking about there is one dedicated core per design document. So if you're going to have like multiple design documents, make sure that you have sufficient CPU cores to handle that. So the bad cases, if I have to put it, if you're going to have like one design document for all the views, which means that the indexer have to do a lot of work at the same time, because it has to run through all the views. And if I'm going to have the other case in which I'm going to have like one view per design documents, I'll have multiple design documents. As I said, you need to make sure that you have sufficient CPU cores, sufficient CPU cycles to handle it. So what does it take? You need to have a kind of a good balance, make sure that you do it, and not to have like too many views per design document, as I said, right? So you should try to see if you can use nickels in a better manner. But if you're using any aggregations like getting a leaderboard or something, views are still good. And if you're okay with the performance, views are still, you can use it. But keep in mind that it's not going to be served from memory, it's going to be served from the disk. So it's going to be comparatively slower. So breaking point, if I have to say, So this is like service go fail all time, so machines go down, but you have to ensure that the application is always running, it's always served. How do you do it? So you can ensure that if you size your cluster properly, you can make sure that the application is served. So let's see the data distribution, just coming back from the 5 factors. So when you want to use one nodes, so one node is always a single point of failure, so I would never recommend having one node to run any test or production environment at any case, because Couchbase is not designed to run on a single node. You won't get any performance with just single node. It's good for a development environment, but if you're doing a POC or a testing, it's always recommended that you use more than 3 nodes to do it. Because to appreciate the scalability and performance, you need to have more nodes to do it. And in production, obviously, you'll not have one node to do it, so right. So 2 nodes, why not 2 nodes? Why do I need 3+ nodes? So when you have 2 nodes, again, you get a replication, but the problem is there is a single point of failure if one node goes down. Again, you are back to 0, right? So there is a feature called auto failover in Couchbase, in case if you haven't used it, which will enable to the other nodes can fail over a node which is not responding. So this will hold good only if you have 3 nodes. So what happens if you have 2 nodes in the sense? There is going to be a split blind scenario. Let's imagine you have node A and node B. So there is a network hiccup, and node A will try to fail over node B, and node B will try over node A. So that's not going to work. So 2 node is equally bad as 1 node. So 3+ node is always good for the production. So which will help you for auto failover, upgrading, and for further scalability. And Couchbase offers the 0 downtime upgrade options when you have like sufficient nodes to handle it. You can even upgrade without taking the entire cluster down. Without even a single timeout, you should be able to upgrade it, add the node, and do a swap rebalance. For example, if I have a 5-node cluster, I can take out the 5th node, upgrade it. When I'm going to add it back, I'll just take the 4th node out and then do a swap rebalance so that the incoming node gets the data of the outgoing node. So with that, I should be able to do it in a way that you don't have to bring down the cluster at any point of time. And it's a kind of a graceful removal. So if I'm going to remove a node, so it's just going to close all the existing connections and it's going to give it to the new guys as those. It's simple. So as I said, that's what I was referring about the scalability. And the minimum requirement is like 7+ nodes. When I say 7+ nodes, which means that it includes 3 data nodes, 2 index nodes, 2 query nodes, which is minimum for a production environment. Although you can start, if you want to start with, you could start with say 5 nodes, 3 for data, and 2 sharing index and query. When you have a powerful machine which has a good number of CPU cores and good disk, and then sufficient memory to handle it. So as the data grows, so what are the implications here? So you should understand that metadata increases as well with the node and with the item count. So you should keep an eye on the working set, the Docker resident ratio, which I was talking about, and also keep an eye on the disk space. So this is likely to grow, and there are indications. So the resident ratio is going to drop off, and then you're going to hit more cache miss ratio. And what do we do? We can do a revise calculating and sizing, or you can add nodes, make sure that you remove unwanted data, right? So to ensure success, so test, deploy, monitor, rinse and repeat. So drills for failover testing. So normally we do performance testing, but we fail to do the failover testing part. So what do you mean by failover testing here, right? So you can simulate failures. So you can simulate disk failures. You can simulate network failures. You can hung the process, cluster failure, try to see how your application works, right? So try to learn from it, try to break the cluster and see how it works. Right, so you know exactly that's what is a breaking point. So to understand like how the cluster behaves, so you should be able to have your application always being served in a way that Couchbase offers you to recover from a node failure, from a group of node failure, from the cluster failure. There are various mechanisms to do it. In case of the primary node goes down, you can read from replica. If there is a portion of node goes down, you still have the data. If you are setting up rack zone awareness, you still have the data available on the other zone or a rack. And if you have XTCR, So obviously you have a cluster which can take care if the primary cluster goes down. So and then stress testing, so you can do the stress testing over nx times. So nx could be like 5x or 10x, depends upon how much volume that you can generate it. So and one more most important thing before we jump on to the last slide. So isolate systems interfering with the performance. There could be certain systems like a third party, a monitoring agent, which would sit on your machine trying to gather some stats about the server. Right? So that could be interfering with Couchbase, because Couchbase is meant to provide consistent high performance. So if you see that there is something that you don't get a consistent performance, so you can find out that there is an agent which sits there, which collects the data, which is bothering. It could be a virus scanner, or it could be a monitoring agent. So you want to identify that and isolate it. So sizing is a tricky business. So work with us. So if you have any questions, you can always feel free to reach us out. And it's always, you can validate your on paper with the testing. So, and constantly monitor in production. So monitoring is always important. So sizing is more of an art than science. So, and again, whatever testing you're doing, it could be different than in the production. So always keep an eye on the KPIs, resident ratio, right? So that will help you to size the cluster properly. Right. So as I said, it's a tricky business, so we need like little more information, and it has to be done on a case-to-case basis. So Couchbase solution engineers across the world could help you and size your clusters properly. So gather your workload, item counts, size, reads, deletes. So you need to understand your pattern, and you should make sure that you do the testing and review the documentation formulas. Thank you. Any questions? All right, we'll take it for 5 minutes. Sure.
For the index services, do you recommend having a redundant index services, like having the same set of indexes that you have on one in another one?
Of course.
So, like, if you want to spread more, so you need more index services. If you want to spread your indexes, for instance, one set here. So, let's say you have one set here, one set, and redundancy for each index services. Would that be a good design?
Just repeat the question.
Yeah, so of course, index services we would need for high availability. You need more nodes, right? So the best part of GSI is there is a centralized location. Again, for redundancy, you still have to create indexes for now, but hopefully, in the coming releases, it will be completely automatic, the index creations. Right now, you still have to go and create indexes on every index nodes that you're going to have.
Right, okay. And the redundancy will have to be rolling upgrade, because that's one issue we have right now. When we do the upgrade, we don't want to have downtime. So if you have redundancy, then we can yank one out. So
of course, you can do it. So if I have to give an example, in memory optimized indexes, although we say that it's completely, it has to fit in memory, it does take a snapshot on disk. So in case of failure, if the machine has to reboot, so it does not have to rebuild the index from the scratch. So it has to read from the snapshot and then get the delta from the other index nodes.
okay, so you don't lose the index.
You don't lose the index, yes.
With 4.1 you do right now. Okay, fair enough, thanks.
Yeah, please.
During your installation, we have an option to pick like a data, indexes, and query. Right?
Yep.
But after that, can we like make it like data only and query only and indexes only?
Yeah, you can do that. You might have to rebalance it out. Yeah.
So to repeat the question, can you change the services after you've installed the nodes? Unfortunately, not at the moment. That's something that we're planning for future release. But currently, you need to take the node out of the cluster, and when you re-add it, you can choose the services when you add it.
Basically, you have to do like a swapping back.
Exactly. Yeah. Exactly.
Yeah. Yeah, please go.
Did I understand you correctly that you recommend against using EVS volumes for
No, it's not against EVS volumes. So there are a number of customers, they are using EVS volumes. So it's not against it. So I was comparing it with SSDs and Fusion IO.
Would you recommend maybe using local storage for indices versus EVS volumes for persistence?
Of course, yeah. Local storage is always preferred, right? So
I want to follow up on that. I'm curious why. Is it strictly that you're assuming local storage is always faster?
okay, so you want to
I'm happy to answer that one. So we have lots of customers that use Amazon Web Services, obviously, and the stated numbers and the IOPS for Amazon Web Services aren't public. They don't really make that public. Our experience is that local SSDs with EC2 is a lot more performant than over EBS.
And I can actually back that up. That's exactly why I'm asking. Is because we find IOPS get very, very expensive going across EBS.
Yeah.
And it's the burst IOPS.
And SSD storage rate comparison is very fast. So it is about throughput.
So again, you can have dissimilar hardware, right? So you can have SSDs for index services, and you can have spinning disks for memory, right? So you can have different configurations based on the throughputs, right? So whatever on the business requirements.
And like Karthik said, I mean, EBS certainly does work. It's not a suggestion not to use them. It depends on your use case.
Feel free to reach us out. In case if you have any questions, we'll also be available in the expert bar. If you have any questions, feel free. Yeah, we'll be publishing the slides. Yeah, sure. Thank you.